Hello, 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 ladies and gentlemen, and welcome back. Welcome back. We're looking at question 3 on the grade 12 Manitoba Math Contest from the year 2009. So question 3a, solve for x. Square root of 3 times the square root of 3 is 3 to the power of x. Okay, so to do this question, we need to be able to convert square roots into exponents, because we've got 3 to the x, and we want to work that out. Remember that if you have exponents of the same base that are equal, that tells us that a has to be equal to c. This is the only way it happens. Okay. Other things to note in this question: the square root of b is really just b to the 1/2. So knowing that, if I've got square root of 3 root 3, well, that's the square root of 3 to the half. Now 3 is just really 3 to the 1. So this is 3 to the 1 plus a half, or 3/2, and we're square rooting that, so that becomes 3 to the 3/2 all to the 1/2. And how do we deal with exponents of exponents? Well, when it's written like this, we can just sort of multiply them in. So this is going to be 3 to the 1/2 times 3/2, or 3 to the 3 over 4, and that's going to be x. 3 over 4 is x. Okay. So very quick, if you're comfortable with exponents. And if you're not comfortable with exponents, may I say this is an eye-opener, and you should be, going and practicing exponents, remembering exponent laws. Nice things to also know: logarithms. They're just the reverse of exponents, but people tend to have trouble with them. So review the logarithm laws. Ask teachers, give me questions involving exponents. I want to practice my exponents. When you find a weakness, you want to do everything you can to sort of close that gap, close that weakness off. So seek out questions that you have trouble with. So that's 3a. Let's take a look at 3b. Solve the equation x to the 5 minus 5x cubed plus 4x equals 0. So we've got a 5th power of x here, and that makes this what we call a quintic equation. And unfortunately, there is no general quintic formula like there is a quadratic formula. So we're going to have to use our tricks to try and solve this question here. We want to try and find factors in order to be able to get this smaller, maybe get this down to a quadratic that we can solve. And I notice every factor over here has an x, so we can factor out an x, and we'll get x to the 4 minus 5x squared plus 4. And now we just need to sort of factor out a quintic, or not a quintic, a quartic here. And there is a quartic formula, but no one memorizes it. It's way too annoying. So what are we to do? Well, notice that this is a very special type of quartic. If you haven't seen this before, this may take a moment to get used to, but we're going to create a brand new variable, and we're going to say let y be x squared. So then I'm looking at x times y squared, because x to the 4 is really x to the 2 all to the 2. Again, being comfortable with our exponent laws will help us out there. Because remember now these multiply, 2 times 2 is 4. And minus 5y plus 4 equals 0. But now we just have a quadratic. And you can use the quadratic formula if you want, or you can factor this. It's not so bad to factor. -1 times -4. Okay. So now I can bring the x squared back in. Because remember, we want to solve this all in terms of x. Okay. Now each of these, quite quick. You can use quadratic formula, or you can realize, hey, this is a difference of squares. And you can factor this as well. Okay. And they wanted us to list out, so solve the equation, fairly straightforward. We just need to list out all the possible values of x. Okay, so we've got all the nice linear terms here. So x could be 0, or 1, or -1, or 2, or -2. These are the only x values that when I plug them in make at least one of these 0. And the only way to get 0 from a product is if one of those factors is 0 itself. So we have solved the equation. X is any of the 5 smallest integers in terms of absolute value. Alright, so that's question 3 all done. We'll flip the page in anticipation of our next question, which is, you guessed it, question number 4. And we'll see you for that in the next video.